With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students, question is variation of the equilibrium constant K with temperature is given by Van Hoff equation, that is ln K is equals to delta R S naught by capital R minus delta R H naught by RT. From this equation, delta R naught R H naught can be evaluated if equilibrium constants K1 and K2 are at two temperatures. So this is the Van Hoff equation, that is log K2 by K1 equals to delta R H naught upon 2.303 R into 1 upon T1 minus 1 by T2. So select the correct statement. So we are given here 4 statements. We have to find out the correct statements. First statement is value of K equilibrium always increases with temperature. So if we see the relation of the equilibrium constant with temperature, it is ln K equals to delta R S naught upon capital R minus delta R H naught upon RT. Now in the question it is given that K equivalent always increases with increasing temperature. It means if we increase the temperature, generally the entropy change value, that is delta R S naught, it increases. But if this value increases, this value will increase, but delta R H naught, it will depend on the reaction whether it is exothermic or endothermic. So if it will be exothermic, then the delta H will be negative, and if it is endothermic, delta H will be positive. So if delta H will be negative, it means in case of exothermic reaction, so this will be positive. It means then the ln K will increase, or K equilibrium will increase with increase in temperature. But if it is endothermic, then this value will be less, then K equilibrium will decrease. So this statement is incorrect, that it always increases with temperature. It will depend upon the reaction whether it is exothermic or endothermic. So this is incorrect. Second statement is for exothermic reaction, value of K equilibrium always increases with decreases in temperature. So if we see this relation, that is log K2 by K1 equals to delta R H naught upon 2.303 R, and this 1 upon T1 minus 1 upon T2 will be equals to T1 T2 into T2 minus T1, T2 minus T1 upon T1 T2. Now for exothermic reaction, delta H is negative. So if this value is negative, and we are saying that the statement is saying with decrease in temperature, it means T2 is less than T1. So this value will also become negative, and this negative and negative, it will become, so total value become positive. So if total value become positive, it means log of K2 by K1 will be greater than 1. So if it will be greater than 1, it means K2 by K1 will be greater than 1, or K2 is greater than 1. It means the equilibrium constant value will increase if the temperature is decreased. So this statement is correct for exothermic reaction. Now C statement is for endothermic reaction, value of K equilibrium increases with decreasing in temperature. So this is the inverse of this, because if the reaction will be endothermic, this will be positive, and with decrease in temperature, this value will become negative. So positive and negative, this will become negative. So it means the value will decrease. K equilibrium will decrease with decrease in temperature. So this is incorrect statement. And last statement is for exothermic reaction, slope of log K versus 1 by T is negative. So if we see this relation, it is log K or ln K equals to delta R S naught upon capital R minus this. So it means the relation is given as ln or log K into 1 by T into 1 by T. So this is the slope of this curve. slope will be minus delta RH naught by capital R minus this by. So it is saying that exothermic. So for exothermic, delta H will be negative. So if delta H will be negative, this negative and delta RH negative, so it will become positive. It means this slope will be positive, but it is given negative, so this is incorrect statement. So the correct statement to this question is the B statement. This is the correct statement. I hope you understood the solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.